Once again, welcome to my channel, PLC and SCADA trainer. Okay. Today I'm going to say one more important topic uh, I'm going to discuss, that is errors and faults, finding the errors and faults in your plant or in the machine. Okay, and there are different types of faults and errors we face uh, generally in the machines, right, and the plant. So let's start. So types of faults, or you can say error in a running plant or in a machine, right? So there are two types generally, and they are differentiated as a functional fault and a system fault. Functional fault. Functional fault, it is related to the field instruments. Okay, it's related to the field instruments, like you are having push buttons, sensors, right? So different types of inputs are there. If they are damaged or if they are not working, then how to check that fault, right? So that it will be a difficulty. So, right? So we have to find out these errors. So where is the error, where is the fault? Okay. Whether an instrument is working or not. That also we need to discuss. Now, here, how to identify that under functional fault, right? So that we can see. Then we are having system fault. That is, it is related to your PLC, CPU, and IO modules, or whatever the peripheral you are connecting on the system. Okay. Now, the functional fault, if there is any fault related to the field instruments, you are not getting any signal to the CPU because it's a hardware error. Okay, that is on your sensor. So there's no signal to the CPU. Whereas if there is any error in the CPU, that is in your program or any input module or output module, like if that module is supporting diagnostic property. Okay, so that we can configure in software itself. Okay, in hardware configuration, we're having an option to select or deselect that error. Okay, for separate input or output modules. Okay, so we get an interrupt signal to the CPU, or if there is any error on the CPU, if your CPU is not detecting that particular input module or any input signal, so that we can give the signal to the CPU. So CPU goes to stop mode. Next, in functional fault, CPU status will be sorry, what will be the CPU status for functional fault and system faults if such errors occurs. That is, in functional fault, your CPU will be in run mode. In this, we are having some methods to check the functional faults. Whereas you can see we are having LEDs on the modules, whether when I operate this particular switch or sensor, okay, manually, so that particular LED on the module is going high or low, high or not. Okay, it's going 0 or 1 or not, okay, on or off or not, that you can see. Another option is cross reference. Once you identify that address, okay, if it is not working, you can cross check that address in the program using this cross reference option. That also I'll discuss in the next video. And monitoring status in the block, that is in your program block, like in OB1, if you have made that program with that particular address, you can check whether that address is going green or not, and or NC contacts you are using, right? Whether they are going green or not when you are operating the switch or that particular signal. Okay, that is another example you can see. and monitoring status in variable table. In variable VAT table, also you can check the status. VAT table like nowadays in TIA portal. Okay, VAT table is in Semantic Manager. TIA portal is called watch table. Okay, it's called watch table where you can watch the status of the input or output. Okay, now these are the methods which you can use to check the functional facts. Here, what is the main thing is there's no interrupt signal and your CPU status will be in run status only because the error is on the field instrument. Okay, so whereas if you compare with the system fault, the CPU status will be depending on the OB you are downloading for that particular error. Okay, so that I will show. I will discuss about the OBs, which OBs we have to download for this particular errors, for which error you need to use which OB number. Then here you can see if that particular OB is present, yes, then your CPU will be run mode. If that OB is not available, okay, if you are not downloading that error OB in your CPU will be in stop mode. If that OB is available, it will be in run mode. Okay, but it will show the error on the CPU. Okay, SF LED will be there on your CPU, so that LED will be in red. You can add it, you can understand that there is an error on the CPU. So to check that errors, again, we are having some methods here for system faults. That is LEDs on the modules again. Okay, hardware diagnostic option is there that we'll discuss further in the next video. And diagnostics option. Okay, and local data. Local data is like for some if you see OB1, if you expand it, there is a one hidden window in that. Okay, so you can expand that window and you can check some local addresses in OB number 1 and in other OBs also, as well as in FCs and FBs. We are using some local addresses as input outputs, right? So here in OBs, there are some predefined local data or local addresses are there that you can directly use for such errors. If it is related to that particular OB number, that OB number error you can use. Okay, these are the important thing you need to understand here. That is the difference between functional fault and system fault. What is a system fault and what is a functional fault? Okay, I think you understood this difference here. There is some interview questions also. Okay, then we discuss about the different OBs we are having in Siemens. The block types and the numbers and their event numbers. So first one is cyclic execution of user program. That is your OB1, block OB, organization block 1. Event number is 1. Okay, for this OB1. So event number is like a priority number, is also known as a priority number, but this number 1 is the least priority. Okay, it is having the least priority. Other numbers like time dependent interrupts. Okay, other OB groups are there. That is, one is time dependent OBs. One is time of the interrupt, which is ranging between OB number 10 to OB number 17. And they are having the unit number 2. So your CPU will compare between these two OBs, OB number 1 and OB number 10. Okay, so it is also comparing the event number, so which is having the higher number, event number 2, right? So it will interrupt your OB1 and execute the OB number 10 or OB number 11, whatever you are using, and only one time and only one scan. Okay, then it goes back to the OB1. That is called time of the interrupt. Time of day means on some particular day or some particular time your process should start. Okay, and when how it should execute means for every 1 minute, for every 1 hour of every 1 day for 1 month, okay? Only once, okay? That will be executed or scanned by your CPU. Another type is cyclic interrupt. In this, again, we are having OB number 30 to 38. Okay, cyclic, continuous. From beginning, when you put your CPU to run mode, from beginning, it starts executing your logic. Okay, but here in OB1, it is executing in milliseconds. Okay, very fast compared to cyclic interrupt. Suppose if I had to scan some logic after few seconds, after 1 second, or after 5 seconds, or after 10 seconds, that logic should be executed only one scan. For that, such logics you can write in cyclic interrupt. For example, PID, okay, in which your data, okay, is changing after some time. If it is taking some time, like say 5 seconds or 10 seconds, it is taking to change any value. Okay, so such logics you can write in cyclic intervals. Okay, for that we're having some event numbers starting from 7 to 15. So again, your CPU will check if you are using some OB number 30. So it will check between OB number 1 and OB number 30. So which is having the highest event number? OB number 30, right? So that will be executed first, then it means it interrupt OB1 and execute this OB number 30 and then go back to OB number 1. Okay. Similarly, we are having another interrupt called time delay interrupt. If there is any error on analog modules, analog signals, okay, and you need to generate some delay. In that delay, if you want to execute any logic, you can use this time delay interrupt. Okay. So these are some group of OBs, OB numbers, which are coming under time dependent interrupts. Interrupt means which are holding your main block. Okay. Then these blocks are executed only once. Only one scan is happening here. Okay. Remember that one. Then we go for the error or fault OBs. Error or fault OBs means if there is any error or any fault occurs, what happens? The CPU goes to stop mode. But the CPU should not go to stop mode. Okay. For that, we are having error OBs. Okay. It's not like if your CPU is not going to stop mode, I cannot find out what's the error. Okay. So your CPU remains in run mode here in this case, but your CPU will show red LED, SF LED, that is your system fault LED, displaying that there is an error on the CPU. Okay. So what are these type of errors? One is hardware interrupt error, which is again related to your analog module, okay, analog signals. So just if I'm getting a signal of 0 to 10 volts, okay, I'm setting low and high range, right? If it is going beyond 0 to 10 volts, okay, my signal is beyond 10 volts. If it is extending, right? So your CPU should show error. It should go to fault, okay? But if it is going to fault, your CPU goes to stop mode. Your CPU should not go to stop mode. In such case, you have to download this OB number 40. Okay, you can download this as an empty block, or you can write any program in that also. Okay, so it's not mandatory to write any program in that. So this we are having some OB numbers 16 to 23. Similarly, we are having another OBs called synchronous errors. Synchronous errors means while programming. Okay, while programming, if I'm making any mistakes in the program. Okay, so for that, if I'm downloading a wrong logic, just like if I'm creating some FCs and FDs, and I'm calling these FCs in some blocks, but I have not downloaded those FCs. Okay, so your CPU search for that FC. If it is not available, what happens? Your CPU goes to stop mode. This is an error. Okay, for that we are having this OB number 121, okay, to check the error. And your CPU remains in run mode, but it does not go to the stop mode. Okay. Similarly, we are having IO access error. If I'm giving wrong addressing, okay, which your CPU cannot identify, so it shows a error. So for that, we are having OB number 122 block number. You can download these empty blocks also. Okay. If such error occurs, the CPU remains in run mode. It does not show any error. Okay. Similarly, we have another type of error group, that is asynchronous errors. Asynchronous means if any error occurs anytime. These errors occurs anytime. So above one is synchronous, means during your programming or wrong addressing, okay, immediately you will get the error signal. Whereas for asynchronous errors, just like we are having some example, like time delay error, means if your time has crossed the limit, execution time is extended. Okay, if I am setting some 150 milliseconds as a maximum time your CPU should take to scan your program, but if it is extending the time, it shows an error. Similarly, rack faults. Okay, so like that, these OBs are range between OB number 80 to 87, and they are having 27 to 28 as a event numbers. Okay, so let's discuss here asynchronous errors. One example. One is time error. Okay, maximum scan cycle time exceeded. For that, we can download this OB number 80. Similarly, power supply error, backup battery failure, that is for 7400 system. Okay, so OB number 81. Diagnostic interrupt, if there is a wire break for your analog signals. Okay, for these modules, you can, it means if there is a wire break, you are not getting a analog signal on the module. So your module show an error. So that is coming on a diagnostic interrupt. Okay. So your CPU goes to stop mode. In such case, your CPU should remain in run mode. You need to download OB number 32. Similarly, for SM400, if you are inserting or removing any module, input signal module, input or output modules, okay, for that, OB number 83. Means if you remove the module in between, what happens? Your CPU cannot detect that module. Your CPU goes to stop mode. This is an error. Okay, but in 400, we are having this option. We can online change the remove or connect the modules, replace the modules, because S7400 system is having a backplane. If you compare with S7300, it is not having a backplane, but it is having one connector. Okay, with that we are it's like a chain connector. By using the connector, we can expand the modules in 300 system. Okay, that's why it is not having this option. Okay, online removal or inserting the modules. So CPU hardware error, incorrect signal level at the ampere base. Okay, so getting such errors at the CPU for 400 only, we are having this option. Similarly, for program execution error, okay, if any module is defective, okay, in such case, we can download OB85. It's like we are having rack fault error. So this is related with this. If there is a like remote IO module is disconnected, Profibus is disconnected. In such case, what happens? This failure, okay, rack failure will be there. Okay, so your CPU goes to stop mode. So you need to download this OB number 36 as well as OB number 85, because it cannot read the process image. Process image means that input image status or that output image status, they cannot, means it cannot read, okay, or write. Okay, so both the block OB85, I think we need to download. Similarly, we are having communication error for this. So these OB numbers are available for different types of errors or interrupts. Okay, so you can download these error OBs, empty blocks for such particular error. Okay, in the beginning also you can download if you know what type of program we are going to make. Okay, so which blocks are required. So those blocks you can directly download to the CPU. Okay. So here in asynchronous errors, OB number 82, OB number 87 are used. Okay. These are the asynchronous errors. Other OB groups, that is restart OBs. Restart means it's just like a refresh. Okay. Refreshing your CPU. Okay. PLC logic. In that, one is warm restart, that is OB number 100. Other one is hot restart. There are three types. Okay. Second is hot restart and the cold restart. So these are the OB numbers for that. And they are having event number as 27. Here, any one of this block you can use, okay, in your CPU. In S7300 system, it supports only OB number 100. So what happens is when you put your CPU to run, this OB number 100 is executed only one time, means it is refreshing your CPU memory, just like a refresh. So once we restart our PC or laptop, we right click and restart, refresh. So what it is doing? It is resetting your memory. The same thing is performed by this OB number 100. So other restarts like hot restart or cold restart, you can perform manually in 300. Whereas in 400 system, you can use any one of this block, okay? Any one of this block, 100, 1 of 1 of 1 of 2. The remaining you can perform manually, okay? In 400 system. Means any one of this block you can download in your 400 system. But in 300, only one block, that is OB number 100 you can download. So remaining restarts you can do manually. Okay, these are what the different OBs, restart OBs we are having in Siemens. Okay. Now, the difference between these cold restart, warm restart, and hot restarts, you can see we are having PII and PIQ memory. PII stands for process image input or digital input status. PIQ stands for digital output status. PIQ, process image output. Then in cold restart, what happens here? It resets completely. It resets your CPU memory completely. It resets your PIA memory, resets your retentive and non-retentive both memories. And your DB memory will be reset to initial value, that is 0. And program execution will be from the first statement in OP1. Similarly, for warm restart, OP number 100, it reset your PIA, PIQ memory and reset non-retentive memory. Non-retentive memory means a memory which does not retain any value. Okay, means overwritten memory. Okay, if there is any power failure, what happens? The data will be lost. Okay, when the power is back, the data will be lost in this non-retentive memory. Whereas in this retentive memory, it retains. So this memory or data will be retained in case of warm restart. And what are the actual value you are setting under this initial value? Okay, that will be retained. And your data means logic is executed from the first statement in warm restart. Okay. Then in hot restart, it's not like this cold or warm. It is just refreshing the memories and retaining all the data. But wherever it is executed, okay, point of interruption. Okay, from that point only, it continues your scanning, okay, your logic. Okay, so these are the differences here between cold, warm, and hot restarts. Okay, so here next I'm going to create a few example or generating some errors, and we'll see how to check the errors here and how to remove the errors. So first of all, what I do is from Semantic Manager, this window, I go to the blocks, right click, create one FC. So you know how to create this FC here, right? Go to FC, FC1, I give some name like FFF, okay? It's a temporary name. Now FC1 I have created. What next I do is I open OB1 and I call this FC1 here. From where we need to call? From this instruction list, go to the FC blocks. You can see FC1 is shown here. So just drag and drop here. I have found this FC1. Now I save the block, OB1. Then I download this one here. So here, I have created FC1 here, right? So this is another block. So this block also I need to select and download, but I'm not doing this here, right? I'm just downloading OB1. I'm not downloading FC1, but I'm calling FC1 in OB1, right? And you see the status here, CPU status is showing run status as green. Okay. Now, once I download this, you can see the CPU status will be like this here, right? And your stop LED will be on and your run will be off. That means your CPU is in run mode. Is in stop mode. Okay. Now, so to check where is the error, what is the fault. Okay. We are having some methods here. The first method is you can check through this OB1 block itself. For that, on your toolbar, go to the PLC option. Here you can see module information. Select this module information. In this, you can see we have some performance data, diagnostic buffer, memory, etc. In this, you can see the part of your CPU and operating mode of the CPU is in stop mode. So this is a stop condition. Here it is showing status okay because we are using simulator. Okay, that's why it is showing okay. Otherwise, it will show error. Okay. Now, under this, to check the error, go to the diagnostic buffer. Select this diagnostic buffer. It is showing the error list here. What is that? The third one, FC not loaded. When you select this, FC not loaded, at bottom you can see the details on event. Event ID is also given here. If this event occurs, okay, I can use this event ID for comparing the error type. Okay, if this event occurs, then show some LED on. Okay, so such programs I can write in FCs or in OBs also. Okay, now, so FC not loaded, FC number 1, DB number, sorry, in OB number 1. Okay, so requested OB, what is showing here, requested OB number 121. Means for this type of error, we need to download this OB number 121. Okay, so what I do, I close this. Okay, one more thing here, you can see stop caused by programming error. Stop caused by programming error. Okay, now means here I have not, I missed some FC or during downloading, some FC or ABs or DBs. Okay, these blocks are missed. Okay, but that also shows the error. So to download this OB121, go to the schematic manager, click on the blocks, insert new object, organize one block. To create one block 121. You don't need to write any program in that, just create the block and download this block. Okay, select this block and download. Now I downloaded this OB121 and you can see the status here. Now it is showing your asset. Now it is still in stop. Okay, so I need to refresh it. So I just put this to stop and run P again. Now you can see the status. It is in run mode, but still it is showing the SF LED. The CPU is in run mode, but still it is showing the SFLD. If this OP121 is previously downloaded, okay, initially if it is downloaded, and if this error occurs, okay, the CPU will show this status only. Okay, SFLD red and run status. Now, another method to check the error, okay, one is from this block we have seen. Another way from schematic manager, go to the PLC diagnostic settings. We're having two options. One is hardware diagnostic and another one is module information directly. Okay. But if you go to hardware diagnostics, here we are having CPU. Okay. With this CPU, you can see it is showing the run status on the CPU. This is a run status. Select the CPU. Here we are having module information again. When you click on this, here it will show this module information. Okay. Now the status is in run, but still LED is on. Okay. So that will be displayed here. That LED is on because LED display is not possible due to simulation. But on hardware it will display. Now it is showing FC not loaded. Okay. It is showing only FC not loaded. So what I do, I just close this one. Close this one. Select that FC number FC1 and download it from here. Now I have downloaded the FC. On CPU, this LED will automatically remove. Okay. But as we are doing with simulator, I need to stop and run it again. Now you can see that SFLD is gone. Means your error is removed. Okay. So this is one example for programming error. So similarly for other errors, okay, so what are the error types are there? I've listed the OB numbers, so you can download that particular OBs. Okay. And one more thing, if I okay, we'll see one more example, another error like analog. For analog address here, the byte number is 800, right? So what I do is I just give another address for this one, 86. Now, I take the memory section here. Up, move PIW 300 on take. Okay. On PIW 300, we use some memory like MW 60 somewhere. I will leave the time. Okay. You can see when I go to monitor at bottom here it is showing the stop condition. Means the CPU is going to stop mode again. Right? Here you can see here the same thing. So what we need to do is first we need to check the error, right? So go to PLC, module information, diagnostic buffer. Was the stop caused by IO access error? Okay. So below again it is showing IO access error reading. It cannot read that address. So what address it cannot read? 300, which is not available there in the hardware configuration, right? So requested OB is IOSS error, OB number 122. So whatever requested OB is there, it is showing for the asking for downloading. You can simply create and download that error. Okay. So what I do, I just create that OB number 122. Okay. Now I just download this block. Then just stop and run again. Okay. So you can see your situation, run more. Okay. As it is in simulation, that's why that error is gone. Okay. So what we need to do, we need to change this again. Okay, to 256. Auto the addresses are available. Change it to that address. Okay. But in the hardware, this error will not be. Okay. So to download this change, then only the error will be removed. Okay, automatically. So this is how you can check the errors and faults. There is two methods. Okay, one from this block, another one means you can also see the input status, okay, on off in this program block, whether the functional fault errors, right, which we have discussed in the beginning. Okay, that you can check here whether the input is coming on or not when the buttons are pressed or sensor is working or not. Okay, we are checking that. Then one method is here, another method is from schematic manager from here, right? One more method you can check from hardware configuration here. In this case, you're having one option called offline online. Okay, so this is presently offline status of your hardware configuration. If you want to go online, when you click on online, okay, it is going online with the PLC CPU. Now it is showing you the hardware status. Okay, present CPU online status. And here also you can check. Okay, you can see the symbol on CPUs on. If any module is disconnected, okay, if any modules are disconnected, it will show the cross mark on that. Okay. Suppose let's see one example. If I calculate it, that means compile, once I compile, then I download this once. I've disconnected this Profibus connection, and then I'm downloading this configuration again to the CPU. This functions are active here. So disable this first. Now I download again. Okay. Now when you go to online from here, okay, as we are downloaded, it is showing this one. But generally it will show cross mark that the system is disconnected. You can easily identify. Okay. Mm. 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 Okay. So this is about the errors and faults and diagnostics here. Okay, to check any errors or faults on the system. If there is any module is not communicating, that's not available, it will show cross mark on the particular module. Okay, with the hardware. Okay, with as we are doing simulation, it's not showing, but with hardware, it will display. Okay, it is about the errors and diagnostics. Thanks.